So this is example A, I guess, from the second set of examples. So we're trying to find all the angles, including angles less than 0 and greater than 2 pi, that have sine equal to root 3 over 2. So first of all, we need to know what one angle is that has sine of root 3 over 2. Over here, and the other one is over here. But you see what I mean. So it's this angle and that angle, and you can figure it out, or maybe you already know. This one in here is pi by 3. Good. Now, it's not only pi by 3, but also, let's see, if you start here and go all the way around once, and then go back up here again, that would be 2 pi plus pi by 3. So that's 6 pi by 3 plus pi by 3, which is 7 pi by 3. Also, you could go backwards around, so starting here and going backwards, and that would get you minus 5 pi by 3. So these two are also solutions. So you can see that you can add not only 2 pi, but you can also add any integer multiple of 2 pi. So here n is an integer, so n is an integer. Okay, so this includes if n is 0, then you just get pi by 3. If n is 1, then you get 7 pi by 3. If n is negative 1, then you get negative 5 pi by 3, and so on. So you could add 4 pi, which would be if n is equal to 2, and then you'd get, let's see, 13 pi by 3, and so on. So, but this is how you list all the solutions to this one, by saying 3 pi plus 2 pi times an integer, or plus some integer number of full turns around the circle, because 2 pi radians is a full turn. Okay, now not only is there this family of solutions, but there's also where theta equals 2 pi by 3, and that's this one. Now this is not included in these solutions that we've already found, because there's no way that you can take a full turn and get starting here and getting here. It's just not possible. Okay, if you go backwards, you here. Things that are a full turn away have the same terminal arm, so we can't draw it with a different line. But they're different numbers, and so we have to consider them as different angles. Even though they have the same sine, cosine, and tan, that's not the whole story. I mean, they're still different numbers, so you still have to consider them as being different angles. Okay, and just the same, we can add 2 pi or 2 pi plus an integer. Okay, and you always have to note that n is an integer. Now, if you want to write this in set notation, you'd need 2 sets. So you'd say theta is an element of the set of angles in R, because after all, angles are just numbers, so you can think of them as real numbers, such that, here's a colon for such that, phi equals pi by 3 plus 2 pi n, where n is an integer. And the other possibility is theta. Now this phi is just a placeholder, so it doesn't matter what variable we use there, but I use phi just to mix things up a bit. And now it's 2 pi by 3 plus some integer number of full turns, which we call 2 pi n, where n is an integer, and that includes going forwards or backwards.